So airline attempts are complex. A single crew member calling in a sick or a sudden weather delay can cascade into cancellations, costing millions. Today, I'm going to show you how I built Aeroresilience, a self-healing rooster agent. So this isn't just a CRUD app that is created, updated, and deleted. It uses multi-agentic system to monitor real-time data, detect disruptions, and automatically negotiate this just like a human operation. So basically, being technical, for the front end, the tech that is used is basically pure React, yes, Tailwind CSS, and a bit and some APIs such as Google Charts API that will be further we using implementing. So in the backend, we have used Python, Fast API, Flask, and for the database, we have used MongoDB, that is MongoDB Atlas, that is a cloud-based database. And the core feature of this project, the core feature of this project is our autonomous and semi-autonomous switchable agentic system. So for now, let's uh, work with the dashboard. So basically now you can see we have flight ID, the routes, their estimated time of estimated time of departure, and the pilot command. So everything is in schedule. So we have used a data set of 5,000 records, which consists of such details and pilot details. Pilot details are demo, but these flight details are have been taken from a real have been taken from 2022 uh, all over all over India data set, which is open source data set, in which it had multiple airlines and their flights dates. So we have modified it for our use. So basically, this is our pilot readiness. Yeah, these are the pilot stats fatigue scores. So I will letting you know what fatigue scores are and how they affect the aviation system. So there are basically two roles uh, in a flight, which are one is our pilot, one is a first officer or flight officer. So these two are the people who are there in the cabin. So now let me show you what we have here. So in this is our pilot readiness. This has stats of fatigue scores and how much risk they have in flying the flight are mentioned here. The percentage of risk. This is our simulation menu. We have the various types of disruptions available here, and this is our live flight data. Live flight data it is not real time, but we are using this as that data is not available publicly, and this is our agentic workflow. So let's see, and this is our crew. So here we have a list of uh, uh, all the pilots and flight officers with us. This is their fatigue scores and their age, their experience, and this certificate. This certificate is mentioned for the flight, which they have recently known. These almost are same as it might change. So and this is the fleet, which consists of flights. So these are various flights that are available here. So let's go to back dashboard. So let's just first I will show you how the manual system works. So now we have set it to manual mode. We have two modes, that is autonomous and semi-autonomous. This is a complete autonomous in which the agents work with each other in completing the task. But in manual, manual approach, it is not the same case. In manual approach, at every step there is a user feedback. When user gives feedback, the operation is performed. So let me just show you manual approach. So let me select which one? Let me select ATC's airline traffic control. So there is air traffic and something like that. It may delay. So simulate technical. So let us select technical disruption. So like I have selected uh, uh, technical disruption. So here the system strategy delayed and the user we have get a critical error and we now have the option to heal. So we have two options. One is cancel flight and one is reschedule. And reschedule will be estimated, that is the flight will be rescheduled after 120 minutes. That is 2 hours and can be further manually changed. So now if I want to reschedule, so it is rescheduled and it is rescheduled for 2 hours in the upcoming time. So let me just refresh it once. So so now we have it refreshed and here is the some status is valid. So now let me show you autopilot mode. So basically in autopilot, that is complete autonomous. These are our agents. This traffic monitor which is continuously monitoring the changes in the our flight system. There will be detection, there will be solver negotiation. That negotiation between which is what should be happen, and then a final execution. So here I will be choosing crew. So crew, I selected crew. So uh, here was pilot was some different name, and now it is different pilot is assigned. Let me just reset and let's show you once again. So now we are back to the reset basic window. So you can see here is flight officer 49 and his fatigue score is 3% and rest is 15 hours. So he is very fit to fly the fight. But due to some conditions, like he is sick, so we are simulating that. So we simulated that the pilot is sick. So the agent were triggered, crisis was detected that the pilot reported sick. Then the agent triggered the anomaly detection, and then the risk assessment of the flight was done. And using the auto negotiation, the option that was selected was to replace the current that was to find the replacement, and the final heal was